Welcome back to our Introduction to SolidWorks video series. So far in this series, we've looked at individual parts in SolidWorks. We've focused on how to create that 3D model using parameters, different types of features, extrude, revolved, swept, bases, lofts, etc. How to modify them using things like patterns and chamfers and fillets, shells and drafts. Now we're going to go beyond individual parts and look at how can you put parts together into groups or assemblies. SolidWorks calls that grouping of parts an assembly. And if you think about it, most of the mechanical devices you interact with in your day-to-day life, they're not an individual part, right? There's very few things that are just one component. Most of them are made up of a group of components. Even something as simple as a pencil, a wooden pencil. There's the wood part of the pencil, there's the graphite lead, there's a metal barrel ferrule at the end that crimps a rubber eraser. So even the most basic things we think about usually are made up of multiple parts. So SolidWorks, like I said, considers groups of parts as an assembly. So I've got a few Lego brick parts open here. You can see these are individual parts that each have kind of a simple configuration and a little more detailed configuration. And I'm going to use these as examples of how we can build assemblies out of individual parts. So as with everything in SolidWorks, you can start from either the welcome screen if you want to, new part, new assembly, new drawing. So far we've done parts and drawings, and now we're going to use assembly. So you could do it from welcome. I'll just go up to new, and again, you can get to an assembly here from the novice version, or if you're in the advanced version, there's a default assembly. You probably haven't created any assembly templates yet, but you totally can, just like we did for parts. But however you want to get to it, we're going to create a new assembly. And you can see that model there looks a little bit like it's starting to stack Tetris blocks or whatnot. And I think the Legos are going to be a good way for us to think about that as well. Wait for it to open up here. Okay, so this is the window you will see when you first create a new assembly. It's a blank window over here in the graphic space. You don't see anything other than the origin down here showing you the direction of the three primary axes. You can see it comes up with a window called Begin Assembly. And it's asking me if I want to bring in some parts. These are the parts that I already had open. So if you didn't have any parts open, there wouldn't be anything in this window, but you could get to things for browse. So let's start by just bringing in one of the things that I had open. So if I click on the 1x4 orange and just leave it selected and then bring my cursor over into the graphic space, you can see my cursor shows a part. And there's a couple different things I can do. I can click in the graphic space and it inputs that part. One thing I want to talk to you about how things come in is your first part that comes in. You can see that our orange Lego block came in. And if you look over in the feature manager, the design tree, you'll see there's a little F in front of it, and that means that it is fixed. So if I wanted to move it, most components, if you grab them and hold down and drag, you can move. But you can see when I try to do that here, it gives me a window saying the selected component is fixed. It cannot be moved. And that's because it was the first thing that brought in. SolidWorks knows that we kind of need to have some base point that we're going to lock everything to. So you can totally do that. You can just bring in a part and have it be fixed. Let's look at how that part is arranged in here. If you look at the assembly tree, you'll see the assembly itself has a front, a top, and a right plane, just like our parts have all along, right? So we see a front plane, top plane, right plane. And your part has the same things, front, top, and right. But let's look at them in relation to each other. If I select my right plane on my part and hit Control and hit the right plane for my assembly, you can see they are not the same. So that part just got located wherever I clicked within the window space. Let's look at a different way I can do that. I'm going to delete that part out of my assembly, make it empty again. And now if I want to get back to that window where I can add things, I just go up to Insert Components. This time I'm going to click on the 1x4 orange. Instead of clicking somewhere out here, I'm just going to hit the green arrow. Okay, now let's look again at the orientation of the planes between the part and the assembly. So here is my front plane for my part, and here's my front plane for the assembly. And you can see that they are coincident. Let's do the same thing for the top plane and top plane. Again, they're coincidence, and same thing for right plane and right plane. So that's just a distinction. If you want to have a part come in so that its planes are coincident with the planes of the assembly, then the way to do that is just to, let's review what we did there. When we're in the insert components, just click on the part and click on the green arrow. That automatically brings all the planes in coincident. If you modeled your part in the perspective that you want to have in the assembly, that's probably the best way to do it. It keeps your origins the same. If you modeled your part from the top, but your assembly is going to be more focused from the front, you're probably not going to want to do that. Then you'd want to click on your part, bring it in, and maybe even rotate it or something. So let's look at how we can connect parts or move parts individually from one part to another. So I'm going to bring in some more parts. Let's bring in a 2x4 blue. Okay, so now you can see I've got a couple parts in there. Again, if I look over at the feature manager, my orange block is fixed, has that F in front of it. My blue block is not fully defined or fixed. So if I grab it, I can move it around. You can see what's going on there. I can move it in all 3 dimensions. That's using this move tool, which the move tool is your default. If you just click on something and grab it and you don't have another tool already selected, you're moving it. Another similar tool under the move is rotate. And so if I grab and hold the left mouse key down, I'm rotating the block about its center of mass. And that's called a free drag rotate, how I'm doing it now. If you look over under rotate component, you can see free drag is selected. Let me go ahead and undo that move that I just did. Let's get it back to where it was before I started rotating it. Let's say I wanted to rotate it, but I don't want to rotate it, arbitrarily about the center of mass. What if I want to rotate it about, let's say, the x-axis? So I just want it to kind of pivot up and down in front of me. Instead of free drag, I'd go to About Entity and then pick what axis I want it to rotate about. So in this case, I want to rotate it maybe around this edge. And now you can see that when I left click and drag, it pivots about that entity instead of about its center of mass. So again, just kind of tricks to help you get things into a rough orientation. Move and rotate. Okay, another trick while we're talking about getting parts into our assembly, let's say I'm going to use a bunch of these 2x4 blue blocks. I could insert component, go back up to insert components, pick 2x4 again. Or another thing I can do is if I just select the part, hit the control key and drag it over, it creates a new part, a new copy of the same part. And so now if we look over in our feature manager, you can see there's 3 copies of the same part. So that's useful when we have the repetitive use of the same part multiple times in an assembly. And those are independent parts now within the assembly. I can move and orient them independently. Okay, so we've talked about how to get parts in. We go up to insert components. Those were 2 parts that were available because I had them open as other parts in my windows. If I want to insert something that I don't have open, I can still do that. I just need to go down to Browse and then look for the part. So let's put in a bigger block. So I'll put in a 2x6 block, and let's add in maybe a smaller block too. So if I want to, I can select multiple blocks at this point. Let's bring in maybe let's bring in a 2x3 red and a 1x2 yellow. So if I select, oops, that copied. Okay, now I've got 1x2 yellow and 2x3 red. Okay, so I've got multiple ones selected. Watch when I click, it's going to bring in the first one, and here it's asking me which configuration of that part do I want to bring in. That's fine, and then when I click the next one, it's going to bring in the next thing I had selected. Okay, so now I've got a lot of parts in there. Let's look at how we orient them to each other. If you think about when we were trying to create rules about how geometry worked in sketches, we used relationships. We called them relations between sketch entities. Those were primarily in 2 dimensions. Now we're looking more at 3-dimensional relationships of geometry, and those are called mates. So if you look up here on your command manager, we've got a mate tab that if I click on it, you can see it brings up a window that looks a lot like our relations from sketches, right? And there's some similar type mates as there were to relations. So there's a coincident, parallel, perpendicular, tangent, concentric. Distance, lock, is kind of like fix, and angle. So these are our standard mates. You can look around in here. There's some more complicated mates. There's mechanical mates. Those are things we're not going to address right now. For now, we're just going to stick with the standard type mates. So let's pick a face of my block that I have fully defined its location, the orange block. And let's say I want to make the end of this blue block coincident with it. You can see it popped up with a smart bar here, and it's making a guess that what I want is coincident. So if I escape from this, let's go back and delete those. You'll see that when I did that, let's do it again, you'll watch it snaps the blue block into what it thinks I want. Its guess here for coincident, it snaps that over there. Okay, so now the end of the blue block and the end of the orange block will always be in the same plane. So if I look from above, I can move the blue block side to side, in and out, but the end of it is always, if I look straight up and down, the end of it, no matter how I move it, is always coincident with the end of the orange block. Okay, so that's a good start. Let's say I also want the bottoms of them to be coincident. We're kind of starting a stack of blocks. So again, coincident, that's good. And then I will make these 2 sides coincident as well. And now if I look over here in my feature manager, you can see that my orange block, right, it has the F in front of it that says fixed, and then my blue block has lost the minus sign in front of it. The blue block is now fully defined in its location. It can't move or rotate at all because of the different mates that I've created. If I want to go back and edit those mates, I can do that just like I could with relations from before. You remember there was the display relations command before. Here I can get to the mates in 2 different ways. If I want to see all of the mates that exist within this assembly, over here in the feature manager, the very last item is mates, and you can see them each listed. And by clicking on them, I can see what features, what faces are active. You can see that one they're hidden, so it's hard to see. But on this one, you can see it's those 2 bottom faces. On this one, it's the 2 end faces. And if I wanted to edit those, I could do that. I can just right-click on and edit it just like any feature. It lets me change what faces I'd selected, what type of mate, etc. So I'm happy with those ones I have in there, though. So that's one way to look at the mates. That's all the mates for the assembly. Another way is to look at the mates for a specific part. So if I open the feature tree, expand the feature tree for this part, you'll see that the first subfolder under that part is the mates in this assembly. So if I open that up, you can see, again, it's the list of mates, and in this case it's all the same mates because there's only 3 mates in this assembly and they're all referencing that part. But we'll come back and look at that a little later once we have some more mates in there. Okay, so let's continue on. Let's say I want to put this white block kind of running out at an angle here. That's a little more challenging than just putting one coincident because I need to rotate it 90 degrees. And the best way to do that in my mind is to use the free drag to get it kind of close to the orientation I want. It doesn't need to be near the position I want, but to have the orientation close to what I want. And then I can do the same thing again. Let's say make this one coincident with that. And in and then we'll do top and top. Okay, so now if we look at the white block in the feature tree, it should also have lost its minus symbol in front of it. Yeah, so it is now fully defined as far as its location. If I grab it and try to move it, it doesn't let me move. The selected component, you see the message it gave me, the selected component is fully defined. It cannot be moved. That's a little different than the orange one. It says the selected component is fixed. It cannot be moved because it came in with a fixed relationship. Let's say I didn't want that block to be fixed. I wanted to let it start being snapped to other ones. I can do that. I just right click on the block and say float instead of fixed. And now if I do that, you'll see the orange block no longer has the F in front of it. And now if I grab any of these three blocks, I can move them all. The relationships between themselves, the mates that define their connections to each other, isn't changed. So they still have to stay in sync with each other, but I can move them around. So let's say I did that and I wanted to, let's bring another blue one next to this one down here. I'm going to mate those two coincident and do the same thing bottoms. And what's left? I can't remember which one I did first. So, okay. Okay, so now those are as a group, and I can still move them, but they'll move as a group. Let's say I want to define them. If you remember back, I showed you how the orange block came in with its planes coincident with the assembly planes. If I clicked OK instead of clicking within the graphic space, let's say now I've got this loose assembly, not loose assembly, but I've got this set of parts that are free to move right now, right? I can just grab any one of them and the group of them moves. And I want to make it so that the, let's say now the front planes of this blue block are the ones, or the front, top, and right planes of the blue block are coincident with the assembly. I can do that. You can make mates between planes just as easily as surfaces. So if I take the front plane of that blue block and do control to the front plane of the assembly, and just make them coincident. And I can do that for top, coincident, and right for both of them, and make them coincident. And now this group is fully defined again. So now if I try to drag on one, you'll see again it says it's fully defined, it cannot be moved. Just pointing out the distinction between fully defined and fixed. Fully defined means it's locked into place by mates, either with the origin planes or with another part. Fixed means you have just arbitrarily said it can't move. For example, I could take this yellow block up here, just right click on it and say fix, and it's now fixed, but it's not really defined by any mate. It's just arbitrarily fixed where I put it. So let me float that back. Okay, so we've talked a lot about the coincident mate. Let's look at another common one. Let's say I want this blue block to be over here, and I want it to be parallel to the white one, but some distance offset from it. I can do that a couple different ways. First thing I'm going to do is make that block parallel. So I'm going to right click on that face, and then right click on this one, and I'm going to choose a parallel type mate. And it went to parallel. So if we look around at it now, we'll see that from the top, those two faces are parallel. Note that it doesn't require anything about that block not rotating as long as that face stays planar. So you can see I can still move that around a lot. So it's partially defined, but definitely nowhere near fully defined yet. Okay, so let's keep continuing on. So I've got it parallel now. Let's say I want it to be coincident on the bottom so that it's kind of like stacked on the same level. And then now let's see what the only movement that I should have left at this point would be distance in and out from that white block. Well, and I guess I still have left to right because I haven't defined that yet. So let's say I want the end here to be coincident. So we're getting close to fully defined. I can still move it in and out. Now let's say I want there to be a 1-inch gap between these two blocks. I'll select both the faces and then pick this mate here that's called distance. That'll bring up a window that says how far apart I want them right there. So I'll say let's say 1 inch. And now if we look at this block over in the tree, you can see the minus sign is gone in front of it, so it's fully defined. And I can also check that by trying to grab and move it, and it's fully defined, it cannot be moved. So that's the parallel and the distance mates. We can do another one perpendicular. Let's say I wanted to stack this block on top of this blue one here and cross over onto that orange one a little bit. Like I said before, I could rotate the component to get it close to the right orientation, or I could, you can always, this is kind of a long way to do it, but just to show you the mate, there is a mate in there that's perpendicular. So if I select these two faces, go to mates, and choose perpendicular. Let's see what it does for me there. Oops, I accidentally unselected that. Okay, and then go to perpendicular. You can see it doesn't know which perpendicular I want. So it's trying to make the mate perpendicular between those, but there's multiple different axes that it can be perpendicular about. So that's not a great way to do that. That's again why I would usually, if I'm recommending it, I will say try to get it into roughly the right orientation so that you can just click on coincidence. Let's look at one other option in the mating that does sometimes throw people for a loop. Let's say I want to stack the red block on top of this blue block here. So I select the top of that and the bottom of this one, and if I say that I want it to be coincident, you can see it assumed I wanted a coincident, so it snapped the block down there. Sometimes that block would snap into the opposite orientation. If you see this little mate alignment option down here on the bottom, you can see that's still coincident, right? The top face of the blue block is coincident with the red face of the other block. It's just flipped the red block about that face. So sometimes when it tries to create its guess, it might have shown up like this orientation with the red block down. And if that's the case, just come over here and click on the align, and it flips which alignment it is. Those are both coincident between those planes. Okay, so now we're coincident top and bottom there. I could continue how I have been doing and make a coincident between these two, but I want to show you another mate that's super useful when you're working with cylindrical features, and that's called concentric. Just like when we were doing concentric circles on sketches, if I select two circular features and pick on the concentric option here, you can see it makes them so that their axes align basically. So now, as opposed to a coincident on a face, I can still rotate this part around. It's just maintaining alignment between the axis of those two circular features. So I could, if I wanted to finish defining this now, I could do it a couple different ways. I could do coincident between these two planes, but let's keep working with this concentric. If I make this boss here concentric with this one, now it's fully defined. Okay, what other types of mates could be useful? There are I guess let's talk about, I've been using faces so far. You can make mates between linear, like two-dimensional features, and even points as well. Let's look at that. Let's say I make a coincidence between this face on the end and this edge here. If I make that coincident, what happens now is you can see it's rotating about that edge. It's maintaining, let's look at it from above again. So it's maintaining that edge that I selected right here. This edge is always going to be coincident with this plane, that leaves a lot of degrees of freedom for the rest of the part, right? I can rotate about that edge basically. So that may be useful. You may have some type of orientation where you want things to be able to move. If you think like, well, this isn't a great example, but a hinge maybe could be, you'd want something like that where it can rotate about an axis. You could do that with concentric as well, like we talked about. That would actually probably be a better application there. But okay, let's take it back. I want to get rid of that mate, or actually what I want to do is edit that mate. So let's go back and look again at how can I go back and find a mate I've created. One way I could do it is, I know the one I want to change is the last one I made. So if I come back over to the assembly mates, this last feature tree item here, they're in order that they were created. So the last one I made is this coincident, and you can see it highlights the orange edge and the fuchsia face there. The other way I could find out if I had this long list and I wanted to find one I'd made previously is, again, just select the part and then go look in the part at the mates for just that part. And you can see there's only one mate for that part right now. So I can right click on that and edit the feature just like any other feature that you've worked with, and I can change either what type of mate it is. In this case, I'm going to delete the edge and pick the face this time so that it's a more fully defining mate, and then I'll do the same thing and create another one. So now we're almost to fully defined. Okay, so all of those blocks now are fully defined. And if you look at our assembly now, you'll see down on the bottom it says right here in the bar, fully defined for everything. If I delete that last mate out, you see it go back to underdefined. So this is kind of a global clue. Is there anything in your assembly that's undefined as far as location, that has some dimension of freedom still about it? Okay, so there is our fully defined assembly with Legos. Let me give you one example, though, of how things can go wrong when you're trying to make mates. Let's say I want another white block in here, so I'm going to control and drag that over to give me another one. And I want to connect it to this blue one over here. So I'm going to rotate it to get it roughly into the orientation I'm looking for. Do some quick mates to the white one to get it close to what I want. Okay, and then let's say I wanted to move this block in. Let's see, do I have room? Yeah, I want to bring this block in so it snaps right underneath here instead of having this gap. To do that, I would want to make this face concentric with that face, or I mean coincident. As soon as I try to do that, you'll see it gives me a warning, hey, this can't be done, and there's a reason for that. It says add this mate and break other mates to satisfy, and the other mates will be broken, or add this mate and overdefine the assembly. So if you remember back to an overdefined sketch, that's when you added too many dimensions to a sketch. You had dimensions that were conflicting with each other. And I've just done the same thing with this mate, right? I'm going to cancel out of this. And let's think about why that is. I'm wanting this block to move in here, but this block's already fully defined. I can see that because there's no minus sign in front of it. And if I look at the mates in it, we can figure out why that is. Does parallel keep it from moving in and out? No, it could still be parallel and move. Is the bottom being coincident prevent it? Nope, that doesn't. And that doesn't. Oh, this distance one does, though, right? I created a mate saying that this face needed to always be 1 inch away from that face. So if I delete that mate, and now I try to make these two ends coincident, that will be allowed, and it should work. Yeah, it did. So that's just an example. If you get that warning saying, hey, you can't do this, it's over defining, go back and look at what is currently confining those parts. And I canceled out. I didn't try to let it do that. Let's undo that last mate we just did. So just delete that one. And drag this out. Let's kind of recreate that situation again by putting in a distance of 1 inch. Okay, so now let me try again to make them coincident so we see the error. And this time I'm going to say add the mate and overdefine the assembly. You can see what happens is now I've got a bunch of red arrows. If I collapse everything, you'll see multiple places it's showing me red arrows because I've got a bunch of things that are conflicting. One of the things that I conflict is that blue block that I'm trying to. The other one is the white block. That makes sense. And if I look at the mates, I can see which mates have the problems. And so you can see some that are giving me issues are the parallels. These are mates that have issues with the block. And this red one is the one that's over-defining. So what you would want to do is come back and look at each one of these and say which one of these kind of yellowed out ones is conflicting with the red one. Which one do I want to remove? And in this case, it's obvious since we just made the example. It's this distance right here that's conflicting. So if I delete or suppress this mate, and I'll just delete it because we're not really dealing with suppression much in these, but I'll delete that mate and everything should go back to being okay now if I rebuild. Yeah. Okay, I hope that's a good introduction to assemblies. Remember, you create an assembly just like you create a part by going to New and Assembly. You add components to assembly using the Insert Components command or tab up in the Command Manager. And you can, if you have parts open, they'll show up here. If you want to add parts that you don't have open, you do that from Browse. What else did we cover? And then mates. So we use mates to create geometric relationships between parts in an assembly. This introduction was just our most basic mates. We'll in the future look at more advanced mates like mechanical mates that allow for power transmission through physical geometry, etc. Hope that's helpful. I look forward to seeing you in the next video. Thank you.